So now we're going for the summary of week 6. So the summary will be based on a CSV file, and the CSV file that I show you here, it's called Weather Zurich and Geneva, and it gives you basically the weather in the week of the public transportation data for the whole week in different stations. So Clo here is Cloton, and you can see here there's a date, 2012 10/06, and it's at 1850. So that's the time. And there's different things you see here, but on the hour you get some report about the weather basically. So the weather is indicated here with those arguments. So the temperature, the pressure, the humidity, the dew point, the wind direction, the wind speed, and the cloud amount and the altitude. So I'm not quite clear why the altitude changes with time, but it seems to change for some weird reason. Okay, so maybe it's the cloud altitude or something like that. So this is presented as a big table, but it's really in the file separated by commas. So, okay, so now we would like to read in this data and to do some analysis of the wind pattern around the three Zurich stations, the wind pattern around there for that week. So, and we would like to plot this as a graphic. So the way I will do this is that it will split into two parts. The first part is a Python module called weather.py that will read in this file, the file you have just in front of you now. And it will read in the data and output it in a way that might be useful for something else. And this something else will be compute the wind rose pattern. Okay, so compute a rose of the wind from there. So I have two files here. You see weather.py and windrose.py. And really, I would like to think of weather.py as reading in the data. So, okay, so it's everything that relates to reading in the data. So there's different stations that are used. There are 5 actually, and Clo, Re, and Sma are the 3 Zurich stations. So you can see Cloton, Affolten, and Fluntern, and then there is Genève and Nyon. So we won't use this. So, okay, what are going to be the different parts? Well, I also want to illustrate everything we've learned so far. So what I will do is I will use first a generator function, and then here a generator list. Okay, so and I will import some other modules to manipulate the data, because we also learned this week. So the first thing I will do is I will assume I have a string, and the string could be of this type. So let me type sample input. So 2012 October 1st, and then 1850, that's the hour. So this is an example string, and it should return some object that is relating to the date and the time. And this is exactly what the datetime module does. So if you if you import datetime and then use datetime.datetime with quite a few arguments, you will get an object here that knows it's a date at a certain time if you want. And the arguments to pass are essentially the year, that's the first part, the month, the day, and then the hour and the seconds. And if you pass all this as ints, and this is what the int here is doing, as ints, then you will have a datetime object that knows how to print itself using different conventions. For instance, the standard UTC convention, you can convert to different time zones, you can convert to different languages probably. You're using a Python module, datetime, that can do a whole lot of things. Okay, so here we will not do very much. We'll just print datetime nicely, but still, that's interesting to know. Okay, and here is actually the main thing we want to look at in this file. It's called weather data. So it uses one argument called the data file, optional, and as default name, I pass the actual name of my function, of my file, and it accesses that data and yields the data concerning Zurich and the wind. Only data concerning Zurich and the wind. Okay, there was a lot more data there, but that's all I want. So how will I do this? Well, I first define some valid station names. So these are the keywords that are used in the file, and these are like human, more readable formats, right? I mean, why is SMA Flunter? I don't know. But anyway, and then I will open the file. So I will open the data file, and then for every line, I will do a line split. Okay, so I probably forgot here to skip one line because this was the original first line that contained the headers. And then for every line in the remaining lines, I will do something. Okay, and I will split the data according to the comma. And then if the data, the very first entry is in the valid stations, and the data 2, and this means the data 2 is present, because if you remember, if you look here, so this is the 0th entry, the 1 entry, the second entry. Second entry is not always present, and this does not contain any weather information actually. So I only want those rows that have Kloten or the other keywords for Zurich, and then things filled in here. Okay, so this is what I'm checking there. So if those are there, then I will define some variable name output to be a dict. And the dict will have some keys, and the keys are station, date, wind speed, wind direction, and wind speed again for different, so knots and kilometers per hour. And then I will pass in I will go fetch the right things. So here would be data 0, but converted to a human readable format. Here would be the string for the date, but converted using the function defined above. And here would just be a float version of this string, a float version of this string, and so on. So you see that the wind direction, degree, the wind speed, and the wind speed again. So maybe the wind speed in kilometers was actually, in knots was actually an integer, in kilometers was a float, but it doesn't matter. I convert all those 3 columns to floats. Okay, and then I yield the output. So that's important because remember, this makes it a generator function. And now I will define a new function that I called high winds. Now ignore just for a second that it's a function, but the second part here is that there will be a certain threshold, and this will be the generator list that returns all the data elements for data in the weather data if the wind speed in kilometers per hour is higher than that threshold. So this part here is a generator list. And what this does is that it defines a function that gives me a generator list for that threshold. Okay, so with high winds and then 10, I would have a generator function, a generator list for all the different data items where the wind speed in kilometer is greater than 10. All right, so this is really giving me access to the data. This file here is allowing me to access the data and defines essentially 2 interesting generators, high winds and weather data, that format nicely everything, read in the data, process it a little bit, and return essentially dictionaries. Okay, so now for windrows. So windrows, what does it do? Well, it will import the weather that I just had, and so the weather module that I just defined, and I don't think I need date time anymore, right? So I don't need it actually. This was a mistake. So, and what does it do? Well, for every data item in weather.highwinds10, so this really means for every time the wind is higher than 10 kilometers per hour, then I should print something. And I can use the fact that now I have a very nice generator here that generates the data in a nice format. So I can print this string where I replace all those in light green with whatever is in the dictionary. Okay, so that's one thing I could do with this this generator here. I could select all the events where the wind was high and above 10 kilometers per hour. But then I can also do a nice other thing, which is a graphic. This is another thing we'll learn this week, is how to use matplotlib. So I will import matplotlib, and I will import pi as well from math, because I'll need it in a second. And then I'll define different data points for Cloten, for Affoltern, and Fluntern. So I'll define a list of those data points, one for each station, one list for each station. And I'll define different colors, so blue, green, and red, completely arbitrary. And then I will start to select all the data points of interest. And I've decided that what's of interest is when the wind speed is higher than 5. And I will save it in the right part of the dictionary data points, right, using the station, and I'll append it to the list I had originally here. So what will I append? Well, a tuple that consists first of the wind direction in radians and then the wind speed in kilometers per hour. And then I will define a new figure, a new matplotlib figure, and it will be, okay, so I'm running out of battery power, as you see. So this new figure will be in polar coordinates, and for every pair of station values in my items, so basically I'll look at Cloten and then the values, I'll look at Affoltern and then the values, and I'll look at Fluntern and then the values. I will define a new data point if you want, but here will be a data pie slice if you want, and it will consist of, it will have different colors, and the colors will be determined by the station and by this dictionary here. And then it will have different values, and this is in polar coordinates. So basically I will have to use the wind direction as the first coordinate, as the angle coordinate, and then the wind speed as the norm. Okay, and now this will define a new graphic, and I will add a title and save it to this file. Okay, so first I will print some data when the high wind is greater in speed than 10, and then I will plot a graphic using all the data. All the data with wind speed higher than 5. So if I do this, I will do Python windrows, and you see that here I'm printing all the different times where the wind was greater than 10. Okay, so on the different directions at Fluntern, at Cloten, and Affoltern. And you see here that I have now created a windrows.png file, and I will look at it, and this is the result. So the windrows for Zurich weather stations, and you see that I've used polar coordinates, and now I have my plots, and in whatever was red, you can see the different colors that correspond to the different stations. And you can see that the wind tends to blow, I guess, from the northeast, or maybe it's from the southwest. I'm not quite sure how this works, but you see some consistency, at least in the direction of the wind, and you see actually extreme consistency for the Affoltern weather pattern for that week. Okay, so I think this was a nice summary of all the different things we've seen this week. I hope you enjoyed it, and I hope you find it useful for your projects to do different things with all those different modules.